Why do zombie fires in the Arctic smolder underground? Why do they refuse to die down? What's causing them? Hello friends, Jim here. Welcome to Science Talk. So-called zombie fires in the peatlands of Alaska, Canada, Siberia disappear from the Earth's surface and smolder underground during the winter before coming back to life the next spring. Why is a question scientists are trying to get a handle on. Most scientists think that zombie fires are the remnants of fires on the surface, but we have identified an alternative cause. Now, who are we? Sebastian Wieczorek, Ian O'Sullivan, and Kieran Mulcroney. Those are the authors of this article. Our research suggests that rapid atmospheric warming above ground can cause peat soils to suddenly heat up to smoldering temperatures underground, all without any spark or other ignition. These zombie fires may be a case of climate change-driven spontaneous combustion. Reports of such fires date back to the 1940s when they were rare events. However, the frequency and intensity of these fires have increased significantly in the past 2 decades, hand in hand with accelerated warming in the Arctic, fastest warming region on the planet, 4 to 5 times faster than the rest of the planet, on average. At the start of 2024, more than 100 zombie fires were active in the Canadian province of British Columbia alone. Zombie fires have even been recorded near the coldest village on Earth, Omuyakon, in northeastern Siberia, where they carried over through multiple winters and account for around 3.5% of area burned in the wider region each year. More carbon is trapped in temperature-sensitive Arctic peat soils than is found in the entire atmosphere. These fires are releasing gigatons of it into the atmosphere. We wanted to know if sudden warming might be directly responsible. So they found 2 interesting results. They developed a mathematical model to explore the different what-if scenarios, including how the temperature and carbon content of peat soils respond to changes in the weather and climate. Crucially, our model captures how certain microbes generate heat while breaking down soil and releasing its carbon into the atmosphere. So what are the 2 results? The first is that those microbes can generate so much heat that underground peat can smolder at around 80 C over the winter, ready to ignite in spring. 80 C. Yowzer. And this can happen without there ever having been a fire in that location above ground, and without the weather above ground reaching high enough temperatures where it's sufficient for the soil to start burning. We call this new state the hot metastable state of peat soils. In this context, metastable means a long burn. The hot state lasts for a long but finite time, up to 10 years, until the peat burns out. So of course that's a function of how much peat is in the region. Our other key finding is that a sudden transition from the regular cold state to the hot metastable state can be triggered by realistic climate patterns alone, including summer heat waves, global warming scenarios. Most interestingly, the increase in the atmospheric temperature has to be faster than some critical rate to trigger the transition. If the atmospheric temperature increases by the same amount but at a slower rate, bioactive peat soil remains in the regular cold state and never transitions to the hot metastable state. So atmospheric temperature has to basically get to a point, a rate that is faster than the critical rate, and then that helps trigger the underground peat into burning. We still do not have proof this is happening, so this is our working hypothesis, and it hasn't been demonstrated in a lab for now. So this phenomenon is only seen in their models. But we do know that compost, similar to peat, can catch fire in the same way. For instance, a large fire on the outskirts of London during a heat wave in 2022 was probably caused by a pile of compost spontaneously combusting. All this suggests that atmospheric temperature is not actually the key critical factor for zombie fires. Rather, it is the rate of atmospheric warming that triggers long burns of underground peat. Simply put, it is not the heat, it is the rate. All right? Come on. It is not the heat, it is the rate. And like with everything else related to the climate, it's the rate of change that really matters. So how do we deal with these zombie fires? As the climate warms, the weather is becoming more extreme. And these are precisely the conditions that can lead to more and more zombie fires. This is concerning as it could kick off a vicious cycle. The gigatons of carbon released from ancient peat soils into the atmosphere are likely to make the climatic changes even worse, which means more fires, so more extreme weather, and so on and so on. Indeed, zombie fires are an example of a rate-induced tipping point, where a system fails to adapt to too fast changes in external conditions and transitions from its regular state to a different, often undesired state. It is possible that the contemporary climate is approaching or has already exceeded dangerous rates of change for certain natural systems, such as bioactive peat soils, which could explain the recent increase in zombie fires. It appears the only solution to prevent further zombie fires is to limit climate variability. While policymakers focus on dangerous levels of atmospheric temperature, heat, climate variability, the rate of change, could be equally or even more relevant to our resilience in the short term. This makes sense. That you're heating up the peat and then it just goes boom. This makes sense. Of course, their work is in the infancy stages, so we'll need to see more of their results as they continue these studies. But I want to take a quick look at this figure here. I guess I'll click over here. There we go. And red areas are warming the fastest, you see indicated here. The black and gray areas, like for example here, right in there in the Amazon, some parts of Africa, and look right here across Eurasia. And these black and gray areas are the carbon-rich peat soils. There is significant overlap between the two, such as in Chersky, which is in northern Siberia, like over here. You can see a lot of the peat soil. There's Chersky. There's a nice big black square indicating lots of carbon-rich peat soil. And it's getting warmer. As the scale here shows how much it is getting warmer per year. 0.07 C may not sound like a lot. That's per year. And it's not linear. So this kind of shows it. What's going on? And there have been some really significant fires that have erupted in British Columbia, in the southern Yukon area, in the Nunavut area, northern Alberta, areas there. There's been some fires here in Alaska. So this is a potential explanation for why zombie fires appear to persist. So there you have it. Very interesting. Until next time.